Today's class we will discuss about Fourier expansion of the function in open interval 0 to pi. Given a function in open interval 0 to pi, whatever be the interval, you find out whether it is odd or even. We have done one problem for even function in open interval 0 to pi, and we have done e power minus ax neither odd nor even function in open interval 0 to pi. So here today's class I have taken a problem from odd function. So we given a function in any interval, the first thing you have to do is to find out whether it is odd or even. So there are functions which are odd, which are even, and neither odd nor even. So we have done problem from Fourier expansion of even function in open interval 0 to pi, neither odd nor even function in open interval 0 to pi. Now today's class I am going to discuss about Fourier expansion of odd function in open interval 0 to pi. So find the Fourier series expansion of the function f of x equals x from 0 to pi, x minus 2 pi from pi to 2 pi. So you are given a function defined in the interval 0 as the lowest endpoint, 2 pi as the highest endpoint. So first thing you have to do is replace x by 2 pi minus x. F of x is defined in open interval 0 to pi. Replace x by 2 pi minus x. Now if I replace this x by 2 pi minus x, I will get 2 pi minus x. If I replace this x by 2 pi minus x, I will get minus x. So I have 2 pi minus x minus x. So 2 pi minus x is minus of x minus 2 pi, minus x is minus of x. So we have negative of the given function minus of f of x. So f of 2 pi minus x is same as minus f of x. Therefore, f of x is an odd function. And then I have sketched the graph. You have to sketch the graph only if it is asked. So what is it from? Well, the function is defined from 0 to 2 pi, 0, pi, 2 pi. So from 0 to pi, f of x is x. So we have the straight line passing through origin. From 0 to pi, f of x is x. So it passes through 0, 0, pi, pi. And from pi to 2 pi, it is x minus 2 pi. So at x equals pi, it is pi minus 2 pi minus pi. At x equals 2 pi, it is 0. So this point pi minus pi, and this is 2 pi 0. So at x equals pi, it is pi minus 2 pi is minus pi. At x equals 2 pi, it is 0. So this point is pi minus pi 2 pi 0. So both are first degree expressions. So they are straight lines. So we have x from 0 to pi and x minus 2 pi from pi to 2 pi. And then I have joined x to x minus 2 pi by dotted line. So we have this wave. We have x and this is dotted line, and then again pi, x minus 2 pi. So this is called a sawtooth wave or sawtooth signal. So since f of x is an odd function, we have the Fourier expansion of odd function in open interval 0 to pi as f of x converging to summation bn sine of nx, where bn is 2 by pi integral 0 to pi f of x sine of nx dx. So we have used the Fourier expansion of odd function formula in open interval 0 to pi. So if a function is odd, you only have to find bn. So what is bn? 2 by pi integral 0 to pi. What is f of x from 0 to pi? X. So x sine of nx dx. So I have told you in an and bn you will be using Bernoulli rule. So 2 by pi integral 0 to pi x sine of nx dx. U is x, v is the sine function. So 2 by pi x into integral sine minus cos of nx by n minus derivative of x is 1 into integral of minus cos minus sine of nx by n square from x equals 0 to pi. So u is x, v is the sine function, u is always a polynomial function, v is the sine function. So u v1 x into integral of sine minus cos nx by n minus u dash derivative of x is 1 integral of minus cos is minus sine of nx by n square from x equals 0 to pi. Now whenever you have sine function, sine in, you check the for the upper and lower limit. If you in most of the problems sine n pi equals 0, sine 0 is 0 will be applied. I have given that formula in the beginning. Sin n pi 0, sin 0 is 0, so the second term is 0 for both the limits. You have the first term 2 by pi minus 1 by n. If x is pi, pi cos n pi, so minus 2 pi by n pi cos n pi, other terms are zeros, pi gets cancelled, so minus 2 by n cos n pi. What is cos n pi? Minus 1 whole power n. So 2 by n minus 1 whole power n into minus 1, that is minus 1 whole power n plus 1. Therefore, the Fourier coefficient Bn or the Euler's constant Bn is 2 by n minus 1 whole power n, where n is a positive integer. Now thus the Fourier expansion of f of x is summation Bn sine of nx. So what is, or summation 1 to infinity Bn sine of nx. What is Bn? 2 into minus 1 whole power n plus 1 by n sine of nx. Take 2 out. So 2 times summation minus 1 whole power n plus 1 by n sine of nx. Expand the summation. Even if you don't write the limits of summation, it is understood that n varies from 1 to infinity. So if n is 1, sin x, if n is 2, minus 1 whole power 2 plus 1, that is minus 1 by 2 sin 2x. If n is 3, minus 1 whole power 3 plus 1, that is 1 by 3 sin 3x. If n is 4, minus 1 whole power 4 plus 1, that is minus 1 by 4 sin 4x plus etc. So if n is 1, minus 1 whole power 1 plus 1 positive sin x. If n is 2, minus 1 whole power 2 plus 1 negative, and n in the denominator, so minus 1 by 2 sin 2x. If n is 3, minus 1 whole power 3 plus 1 positive, so 1 by 3 sin 3x. If n is 4, minus 1 whole power 4 plus 1 negative, so minus 1 by 4 sin 4x plus etc. So we have got the Fourier expansion of the sawtooth signal or the sawtooth wave. So what is f of x? It is a sawtooth wave. The sawtooth wave is expressed as a series of sines. Now you are asked to prove that 1 minus 1 by 3 plus 1 by 5 minus etc. equals pi by 4. So if you are asked to prove something or deduce something, you take the Fourier expansion as 1, and whatever you have to prove, take it as 2. So from now you compare the series part, that is this series part, the bracket term, and this. So guess the value of x. So if x is 0, sin 0 is 0. So RHS of 1 will be 0. If x is pi, sin 2 pi, sin 3 pi are all zeros. So RHS of 1 is 0. So but we want 1 minus 1 by 3 plus 1 by 5 minus etc. So you know that sin pi by 2 is 1. So take x as pi by 2. So at x equals pi by 2, it is pi by 2 belongs to the open interval 0 pi. Pi by 2 belongs to the open interval 0 pi. So at x equals pi by 2, x equals pi by 2 belongs to open interval 0 pi. So f of x is continuous at x equals pi by 2. Whenever a point belongs to the open interval, it is continuous. And f of pi by 2 is pi by 2. At x equals pi by 2 is somewhere between 0 and pi. So at x equals pi by 2, f of pi by 2 is pi by 2. At x is f of pi by 2 is pi by 2. So it is f of x is continuous at x equals pi by 2. F of pi by 2 is pi by 2. So take x as pi by 2 in 1, sin pi by 2 1, and here minus half sin 2 pi by 2, that is 0. 1 by 3 sin 3 pi by 2, sin 3 pi by 2 is minus 1, minus 1 by 4 sin 4 pi by 2, sin 2 pi is 0. So sin pi by 2 1, and here you have sin pi 0, sin 3 pi by 2 minus 1, and here sin 2 pi 0, sin 5 pi by 2 is 1. So on simplification, f of pi by 2 is pi by 2 equals 2 times 1 minus 1 by 3 plus 1 by 5 minus etc. So on simplification, f of pi by 2 is pi by 2 equals 2 times, this is 1 minus half into 0 plus 1 by 3 into minus 1 minus 1 by 4 into 0 plus 1 by 5 into 1 minus etc. So on simplification, 1 minus 1 by 3 plus 1 by 5 minus etc. equals pi by 4. So this completes the problem.